Alright, boys and girls, welcome back to the drive-thru. Here's another doozy. Now, I think that this is off because of maybe this is coming from the screenshot from a Mac and maybe it doesn't like, but I don't even know what this says, honestly. But I can find dydx, I hope, but I don't know what the answer is supposed to look like, but I trust myself here. This one I think we can handle. When we differentiate implicitly, we are almost always differentiating with respect to x. If we differentiate something with respect to y, then we have to basically use the chain rule, which says we have to multiply by the derivative of that function, which is dy dx. So that's implicit differentiation. So here we go. We got x to the 9th y minus xy to the 9th equals 3. We're going to take the derivative of both sides with respect to x, but what I want you to understand is that this is one function, that's two functions, that's the second function, that's the third function, and that's the fourth function. So we're going to have to use the product rule on both of these steps, okay? So when we differentiate both sides with respect to x, for this little thing right here, we'll do that in blue, you have first x to the 9th times the derivative of the second. What's the derivative of y? Well, the derivative of y is 1. But since we took the derivative of that with respect to y, we have to multiply by dy dx. That is implicit differentiation. It's also the kind of the chain rule. All right, so we did first times the derivative of the second, plus second is y times the derivative of the first. The derivative of the first is 9x to the 8th. Okay? So that is the derivative of this thing over here. Now we'll take the derivative of this. So minus parentheses, the red is just the derivative. First is x times the derivative of the second, or well, this is now third and fourth, but you get the idea. The derivative of y is y to the 9th is 9y to the 8th, but that's the derivative with respect to y. We're differentiating this with respect to x, so we have to multiply by dy dx, because that's what we're trying to find, changing y in terms of x. All right, so first times the derivative of the second, plus second y to the 9th times the derivative of the first, which is just 1. And we still have an equal sign, and the derivative of 3 with respect to x is 0, so that kind of makes it a little nicer. So what do we have here? I'll just clean it up, because we got some things to distribute. We have x to the 9th dy dx plus 9x to the 8th times y minus 9x y to the 8th, just changing the order of multiplication right there, times dy dx plus y to the 9th equals 0. Now your next step on this is to get everything that involves dy dx on one side and get everything else on the other side. So what we have, x to the 9th minus 9x y to the 8th. Those are the things that are being multiplied by dy dx. So now maybe you know why Miss Helgeson always made you factor. Equals, now let's move this thing and this thing over to the other side. Well, how do we move it over? We subtract it. So over here we'll have negative y to the 9th minus 9x to the 8th y. Okay? We subtracted those from both sides. That also indicates why the 0 is gone. So, what is dy dx? Well, we just have to divide both sides by x to the 9th minus 9x y to the 8th. And you get this. That's what dy dx is. Okay? And I think uh-oh. Was that, where did we get x to, oh, that should be x to the 9th? X to the 9th? They got x to the 8th on the bottom. Oh, I see what they're doing. This is supposed to be x times, so they factored an x out of this term right here, and that's what that notation is, but screw that, I ain't going to do that. You see that, Elias? So what they did was they took an x out of this, and then what they're trying to tell you is that the answer is x times x to the 8th minus 9y to the 8th. I'm confident that if you typed in what we have here, it would take it. If it didn't take it, you bring that right over to me and we'll go ahead and override it. Veto powers. Boom!